Swayam Prabha. Digital India. Educated India.
Okay, in this lecture we are going to be talking about artificial neural networks. We have been looking at the corpus from the perspective of the numbers first, and then we started looking at some context related to the words and so on. Later we started predicting the next keyword in a given sentence, and then later we started looking at what could be the probability of a given sentence by using the history that we have captured through the corpus. Are you able to really follow the kind of transition that we are getting into, right? Slowly and steadily from the numbers to the context and then to understanding the sentence and so on, right. We are going to be looking at another tool in this which would be called as ANN or artificial neural network, which would also help us in terms of understanding whatever we had seen so far. So, this is yet another mechanism to process the corpus and then get some insights out of that. Okay. So, our journey has been so far in terms of first identifying what could be the meaning of the word, right, and then finding out what are the similarities or similar terms associated with the with every word in the corpus. I am also sure that you have now captured the idea of where we are going in terms of identifying the word meaning and so on, right. The word meaning is related to the context that we are talking about. It is not about the exact dictionary meaning or trying to figure out what could be the synonyms and so on. So, even though we get there using the context available, all right. So, here what I am going to be doing is I am going to be talking about why we need neural networks. Okay. So, why can't we just write the way we write algorithms and then solve problems in the natural language processing. So, why no tool, right. Then we will talk about what is missing in the standard algorithms, right, in terms of creating new rules or in solving certain problems. Okay. And then we will get into the definition of classification. We have seen this earlier. Again I will get into the definition of classification and then show you how we can classify a set of points in a linear fashion. So, that is where we will start in terms of the classification, and then we will talk about the linear models for classification, and then we will find out what a decision boundary is, and then later get into the artificial neural network, because we require some kind of a fundamental to get into the artificial neural network. So, we will talk about these elements before we get into the actual artificial neural network. We will talk about perceptron, is not listed here, the basic element of the neural network, that is how it all started, and then we will define what is meant by learning in a perceptron, and then we will define loss function, cost function, what are the limitations of the perceptron, and then how do we iterate to really get into the solution by descending down slope using gradient descent. And then later we talk about feed forward network and some application related to feed forward network, right. Okay. So, this is something that you all know very well. I do not have to explain to you in detail what we do in the standard algorithmic approach, correct. So, I just briefly mentioned what it is, even though you know all of these. This is nothing but a sequence of instruction to solve a problem, very simple, correct. The steps to solve the problems are very well defined. So, we know what is the input, we know what are the rules to manipulate the input, and then we know what we expect out of the program, okay, as output. And then the steps are coded in some ordered sequence to transform the input from one form to the other. Rules are very unambiguous, right. So, this is something we do very well, without specifying the rule it is not possible to solve any problem in the algorithmic fashion. So, we need to be very clear about the domain, we need to be clear about how to define the rules, and then how we can manipulate the input using the rules, and then later get some output based on those. So, we know very well about the domain to solve the given problem. Okay. So, why do we need machine learning? First of all, we should understand what we learned, right. As a human being, we have been learning right throughout, right from the day we are born, we start learning things, right. For example, a newborn child, right, after 10 days old or 12 days old, the family start introducing the family members to the newborn baby, right. Oh, okay, this is your dad, this is your grandpa, this is your grandma, this is your sister, brother, and so on. Poor kid, right, has to listen to what you are saying. I am not sure what it really understands, it only looks at you, and then you keep feeding that info every time, reinforcing that without giving any input to the child, correct. So, we do not tell the child that your father looks like this with all features, and you do not describe any of those. You just mention that this is your father, this is your mother, this is your sister, and so on. If think about what we are doing with the machine, right. So, we very clearly mention what is the input, what are the rules to manipulate the input, and what the expected output, and so on. For the poor newborn baby, we do not give anything, but we just feed the outcome, right. So, we just show what is the output, and then ask the child to interpret everything, figure out what are the features for the mother, father, and so on. So, we get into similar problems even in the real life here. For example, you are looking at a car, from above, you are still able to recollect, I am sorry, you are still able to find out and say that okay, a car is standing there, but if you are close enough, you will be able to even recognize what that car model is, and so on. And if you look at the car from any direction, top, side, front, back, and so on, you are still able to recognize that, right. So, how do we do that? So, what kind of features that we feed into our brain so that we are able to say that this is a car and this car model is, right. So, these are certain kinds of problems that we want to solve. For example, a face recognition is one example. So, if you are looking at the camera like I am doing right now, okay, without turning my face in this fashion, and every time when I come in, if I have a face recognition software and I am standing at the right distance from the camera, it should be able to recognize my face clearly, right, based on the distance between the eyes, maybe distance between my eyebrows and the mouth, and lots of features that you feed in order for you to really recognize whether that person is a human or not, right. And then we have speech recognition. You keep talking and there is an application that recognizes your continuous speech, right. For example, when I am talking, I am talking about this speech recognition, right. So, when I am doing it quickly, recognize speech, recognize speech, recognize speech, right. It's so fast that it's difficult to distinguish between whether it is recognize speech or recognize speech. So, based on the context, we will be able to figure out whether it is the first one or the second one. So, for that we require some kind of a features to be extracted which are not going to be provided as a rule in terms of the algorithm. So, the system has to really pick up based on the features that are available and then figure out the rules, construct the rule, and then based on the rules it has captured from the data, it should be able to give you some output. Same way the handwritten character recognition, right. So, there are so many ways you can write 8, some people write 8 this way, some write this way and so on. See, for example, some people write 7 like this. Is this 1, or you can, is it 1 or 7 underlined? Okay. So, there is way in which this could also be 1, right. Is G or 9 like this, right. So, this requires certain intelligence and rules that needs to be extracted from the data, which are not going to be available as part of the fixed rule set that you input in your algorithm. So, these sorts of application you need to build the rules based on the examples that are available, based on the data that you have captured so far and so on. Okay. So, for that you can't go for the standard algorithmic approach. Okay. The examples are really helpful in this case. So, if you keep feeding lots and lots of examples of this type and then keep reinforcing during the training time that what I am feeding is 7 and not 1, and what I am feeding here is 1 and not a 1 underlined. So, you keep reinforcing during the training process. Okay. So, during the training process there are experience gained, and those experience would be useful in the real life situation. So, that same thing happens to us as well, right. So, we keep looking at certain examples before we solve a similar type of problems, let us say in maths or physics or any other engineering subject. So, we require some examples to start. So, in the same fashion we might be able to provide a good examples, so that system learns from the examples. So, they give certain patterns which are captured by the system. So, certain patterns are not clearly visible from the data. So, system should be able to really figure out those latent patterns which are hidden inside based on the examples that you have provided. So, we expect the machine to really do these jobs. So, you know well that the machine is capable of doing the computation really fast, whereas the thinking part is not that great when compared to the human. But based on the examples, if it is able to really extract the patterns and then using those patterns somehow it is able to match that pattern with the incoming new set of data and then say that it may belong to this, that is a great improvement, right. And that is what exactly we want to do in the machine learning. A pattern gives the ability to predict some outcome or help in constructing an approximate model. So, what all happens, if you look at the normal or the standard programming model, we do like this, right. So, let us say that this is your input and this is your output, and this is your, let us say, your model that contains all the rules and other processing capabilities, right. And what we are going to be doing in the machine learning is, this is not known, this is a black box. What all we know is there are certain types of inputs that we have, and then these inputs have some correspondence to the output. So, we know that the input and output are related in some fashion, and we want to find out what is that relationship between these, and that is what we call as the model. Okay. So, that model is going to be estimated based on the examples that we start providing to the system. So, that is where we start looking at the pattern. The system starts looking at the patterns, we are also very good in terms of identifying patterns. The same fashion, system also identifies a lot of latent patterns inside and start building some approximate model. That is what I mentioned in this particular bullet point. So, when it starts looking at the new examples and then start figuring out that this could be one of the patterns that I had already seen. So, I can approximately club this particular input along with the existing patterns that I have stored as my model and slightly update the model. So, that next time when a pattern of this type comes, I can provide the output related to that pattern. So, that is what is called as the learning. Learning is an important aspect in the machine learning as well as for the human, right. So, we are all lifelong learners. So, in the same way machine also going to keep learning the new patterns that are coming in. So, it's very similar to what we do, right. Suppose if you have learned some subject and then you are very thorough with that and you have not updated yourself, but you are able to answer most of the queries related to what you have learned, assuming that the particular subject had moved ahead in terms of research and content and you have not updated. And if somebody asks you a question related to the new field, you won't be able to answer clearly, right. So, you may understand that it belongs to the subject that you know very well, but you won't be able to give a very clear answer. So, what you do, you start learning, reading about it and so on, and then looking at various examples of the new topic in the same subject, start learning one after the other. So, you keep learning and updating yourself every day, right. In the same fashion, the models are not going to remain static. So, they are going to keep changing based on the environment. Supposing if the model has learnt every pattern related to a certain object, then there is no need for you to really update that model. But I think that scenario won't exist. There will always be something new and the model will be updated on a regular basis, and that is what we call as the learning. When you keep changing the model that we are building, we call that as the learning process. So, in the case of the machine learning, what happens is since we know that the input and the output are somehow related and we start with the known samples. Okay. So, let us assume that there are some binary examples. So, if I feed in 1 and 1, the output will always be 1. If I feed 0 and 0, the output will always be 0. Suppose if we know these kinds of patterns, right. So, we know that this is the input and this is my output, and since we do not know the model that transforms the input into the output, we start providing certain weights or variables into the model, and that particular set of parameters will keep changing depending on what you are trying to teach the system. For example, when you provide this numbers 1 and 1 initially, and if the model parameters are not known initially, you just set some random values, but you know what the outcome is going to be. Based on the random value, it just creates a rough model and then output some value which is not, let us say, is equal to 1. Then you tell the system that what you have computed is not close enough and it is equal to 1 and you have computed something greater or less than 1. So, correct this, and then based on the correction, the model parameters are updated and so on. So, once you fed all the inputs and the corresponding output related to that and then train this, the system is going to be in a state where when you give the input that you have used for training, it will always give the expected output. So, at that time you claim that the model has been built and it is ready to do the real time real life job. Okay. So, this is what is machine learning at a very high level. So, how is it useful in the natural language processing? So, what is that we are going to be doing in the natural language processing with machine learning and so on. We already have a model where we can estimate the next word, we can figure out what could be the probability of a new sentence based on whatever corpus that I have used. I have already estimated all the parameters and so on. I already have a model. What new that we can do here? Okay. So, we will talk about that as we move along. So, one thing that we are definitely going to do with the machine learning is to look at the classification aspect. We are going to be looking at the word embedding. You remember we spoke about the word embedding in the LSI model where we used SVD to figure out the latent patterns inside the term document matrix, right. In the same fashion we will do the word embedding extraction using neural networks, and then later we will also get into the aspects of learning a sentence. How can I encode a sentence, which we have not seen in the probabilistic model. So, how do I encode a paragraph? How do I encode a problem statement? How do I translate from one language to the other? Again, you can use the statistical machine translation to do that, but what is so great about machine translation we will see in the later lectures. We will also talk about how conversations can be modeled and so on.